Hello students, in this video I'm just going to explain about the Gauss law and its application. This has been proposed by the scientist Gauss and it basically relates the electric flux and the total number of charges enclosed by that surface. Before going to know that, we need to get clarified two things. One is area vector and electric flux. These two things are we have already discussed. So what is meant by area vector means if it is represented as ds is equal to n ds, which is the area vector always perpendicular to that surface. If suppose you are taking any surface, the area vector always pointed like this, perpendicular to that particular surface. If suppose I am taking a surface like this, the area vector points perpendicular to that. ds is equal to the surface I am taking means the area vector of that one can be represented as unit vector n cap into ds. Next is the electric flux. Electric flux is nothing but it is defined as the total number of field lines passing normally to that surface, that is perpendicular to that surface, or number of field lines linked with that surface is called electric flux. If suppose I'm taking any irregular shape, in order to I'm just wanted to find out the electric flux in that, I'm just considering a small portion, that is small area, that is ds, which is of some inclined portion. If it is inclined in some direction means it makes an angle theta. So I'm just wanted to write the electric flux through that small surface ds. So I'm just writing the small value, that is small flux, that is d phi, which is equal to e cos theta into ds. I'm just rearranging the cos theta. D phi, that is equal to e ds cos theta. D phi, which is equal to we can write it as any the product of dot product of any two vector can be written as a dot b means ab cos theta. If it is a cross product, a cross b is equal to ab sin theta. This is we have already done it for the previous classes. This is of the form of this one. E ds cos theta can be written as e dot ds. So if we wanted to find out for the total surface, just we have to integrate. Integration of dx means it is x. Integration of d phi will be phi, which is equal to this side also we have to integrate it. This is a line integral. Line integral means the integral and you have to put a circle like this. This is called as a line integral or surface integral, whatever it may be, e dot ds. Next is we are going to proceed with that Gauss law. Gauss law is defined as the total number of electric flux through any closed surface is equal to 1 by epsilon naught times the total charge enclosed by that surface. It can be represented as phi, which is equal to q by epsilon naught, where epsilon is the permittivity of free space, or this expression can be written like this: phi, which is equal to integration of e dot ds, which is equal to q by epsilon naught. Further, we are going to look at the proof of Gauss law. For that purpose, I'm just taking a spherical structure. A spherical structure means a ball-like structure in which a charge q is placed inside. So it will create electric fluxes, electric field lines, which passes through all the surface area of the spherical surface. So in order to prove the Gauss theorem or Gauss law, I'm just considering a small portion on the spherical surface, which is ds. So in this surface, the electric flux will be linked through it. So for that case, I'm just taking a d phi is the flux linked with the surface of ds, which is equal to e dot ds. So d phi, which is equal to, we know that E is equal to 1 by 4 pi epsilon naught q by r squared r vector, that is unit vector, dot into that is ds can be written as ds also can be written in the form of area vector n cap ds. So dot product of any two unit vector will be 1. R vector dot n cap will be equal to 1. So d phi, which is equal to q by 4 pi epsilon naught r squared into ds. Further simplification, phi, which is equal to q by 4 pi epsilon naught, just they are integrating. Integration of ds becomes yes, because e is constant, just we are taking it outside, so integration of ds becomes yes. Next step, phi, which is equal to q by 4 pi epsilon naught r squared. S is nothing but it is a spherical surface, so area of a sphere is 4 pi r square. So just the surface area can be replaced by 4 pi r squared. So 4 pi will get cancelled, r square will get cancelled. So phi will be equal to q by epsilon naught. This is what the statement given by Gauss. What happens if any surface is not including any charge within that? So just for that case, I'm taking a cylindrical surface. I'm dividing it into 3 parts, the surface 1 and surface 2. This is the lateral surface area 3. So the total flux will be phi is equal to flux linked with the surface 1 plus flux linked with the surface 2 and surface 3. So flux linked with the surface 1 can be written as, this is in the opposite direction. This is what the field direction. This is in the opposite direction, means minus E surface 1, and flux 2 is equal to E is along the direction, so it becomes positive, and surface 2 along the surface 3 it is parallel with the field applied, so there is no flux linked with the surface. So hence the total flux will be equal to minus ES. The total flux will be written as minus ES plus the ES get cancel each other. Phi will be equal to 0. Hence from this one, this is a simple explanation given in your book, but blindly you can mind it. Q, whenever the charge is 0 inside a conductor or any surface which you are considering, so the flux also will be 0, because in this expression, if you are putting Q as 0, entire thing will become 0. Blindly you can mind it as, if Q is 0, the flux is also 0. Next is then some of the important points related with the Gauss law. Gauss law is true for any surface which is closed irrespective of its size and shape. Gauss law can be applicable only for the surface which is closed. For any surface which is closed irrespective of its size and shape. Otherwise, that is the shape and size will not be matter for this case. Next is Q equal to sum of all charges located inside. Charges can be located anywhere inside the surface. If you are considering any closed surface, that is ball-like structure, if you are keeping any charges inside, it will be the ball can have so much of charges. The Q can be represented sum of all the charges present in the surface which you are considering. Next is the surface chosen for the application of Gauss law is known as Gaussian surface. The surface which you are taking, any kind of surface that you are taking for the application of Gauss law is known as Gaussian surface. This is a very important term. Next is it is used to calculate electrostatic field when the system has some symmetry. It should be applicable only for the case of the surface that you are considering should have some symmetry. It may be of either spherical symmetry or any other symmetry like that. The final one is charges in motion. If the charges is in motion, it cannot be, for that cases Gauss law cannot be applicable. So only for the case of charges to be at rest, the Gauss law can be applicable. If it is in motion, the Gauss law will not be applicable. Here are some more important points related to Gauss law. The first one is electric flux due to a negative charge. Look at the image. The negative charge minus q is placed inside any surface. The flux will be flux always will radially inwards. So the relation becomes phi, which is equal to minus q by epsilon naught. The next one is the electric flux due to a positive charge. We know that plus charge always emits the field lines radially outwards. The equation becomes phi, which is equal to plus q by epsilon naught. Next is the third point, the electric flux due to a dipole. Dipole, we know that two equal and opposite charge separated by a short distance, because two opposite charges means the charges field lines emitted by positive and negative charges get nullified. The total outward flux will become equal to the total inward flux. So hence for a dipole the electric flux, that is phi, which is equal to 0. And fourth point is there are two different cubes are given. Both are having a plus charge in it. One is larger in size and another one is smaller in size. The image A is having a larger size and B is a smaller one. So the flux, electric flux, which has a greater electric flux? The answer is given below, because the options are given below only because already we have studied size is no matter. So both the shapes can have a same electric flux. So the answer is C, phi A, which will be equal to phi B, because I've already mentioned that both are having, it is not about the size. Fifth one is, if uncharged body or uncharged surface is placed in an uniform electric field, what will happen? So uncharged body means the charge is 0 there in it. So when there is a no charge, so what will be that? Flux is also 0.